guys, this is a video on slope, which is also known as rate of change. Guys, please remember that this is a huge objective in your 8th grade math, so I want to make sure that you guys understand everything that it has to deal with. First thing that I want you guys to know about slope is that it is a measurement of rise over run. Slope and rate of change mean the same thing, so you may hear those terms be used interchangeably, okay? There are two types of slope that they talk about in the very first lesson with slope and rate of change, and they are positive slopes, which looks like this, and negative slopes that looks like this. I want to show you guys the difference between a positive slope and a negative slope. What you have to remember is that when slope is in a graph, you read slope like you read a sentence from left to right. If from left to right you pick the line up and the line seems to be increasing, it's a positive slope. If from left to right you read the line and the line goes down and it's decreasing, that's a negative slope. All right. Next thing, guys, I want to make sure that you understand is how to find the slope from a graph. There are lots of slopes and graphs in this first lesson. I want to make sure that we do 2 of them to make sure that you guys understand how to find slope. Okay? Now, guys, remember I just told you that slope is a measurement of rise over run. So whenever you see the variable m, that means slope. Okay? So I've got m equals, because I'm going to find the slope for this line. I'm trying to find its slant. What is the measurement of rise over run? So what I'm going to do is pick 2 coordinates from this line. By the way, when I look at this line is a positive line, because just like I read a sentence from left to right, the line starts down here in the 3rd quadrant and makes its way up, increasing to the 1st quadrant. So I already know that my slope is going to be a positive. What you need to do is pick 2 coordinates that happen to lie on this line. The first coordinate that I see is -4, 0, and the second coordinate is -2, 3. And you're going to rise up and then run over to find your slope. If you can simplify that fraction, you want to make sure that you simplify it. So to travel from here to here, you rise up. And guys, when you rise, you want to go straight up and then go over. Okay, so you're kind of making like a triangle. Rise over run. How many do we rise up? 1, 2, 3. So the rise part is 3. Then run over. 1, 2, over 2. Okay, so the slope is up 3 over 2. If I had to write that in the form of a fraction, I would write it as 3/2. Okay, and because the line is positive, it's positive 3/2. Let's do another one like this. Now, guys, you can tell from left to right this line is decreasing. It starts up here in the 2nd quadrant, but it ends up down here in the 4th quadrant. So I already know that my slope is going to be a negative. You pick 2 points on this line. I'm going to pick the points 5, 0 and 0, 3. Okay? This time, because it's negative, I went on and put my negative sign. And then remember, it's rise over run. So I'm going to go up and over. Remember, you're going to go on a straight line. How many would we rise up? 1, 2, 3. And then go over. 1, 2, 3, 4, 5. So my slope would be -3/5. Not so much because, guys, I went in a negative direction, but because the line goes down from left to right. So my slope is -3/5. Guys, you can also find slopes in tables. I want to make sure that we talk about those. Guys, there's something that you should notice. When we were finding slope on the graph, remember that slope is a measurement of rise over run. You guys know that the rise part comes from the y-axis and the run part comes from the x-axis. So all you have to do is treat your tables the same way. How many are we rising on the y-axis? So you would only look at the y coordinates to find the rise. Then how many are we running on the x-axis? You would look at the x coordinates to find the run. Okay? So when we look at all the y coordinates, I've got 1, 2, 3. We can tell that it is increasing. Each term is increasing by 1. That's the thing about slope. Slope always stays the same. So in we're looking for rise over run. The rise part would be 1, because I'm going up by each term, and it is positive. Then you would look at the run part, 3, 4, 5. That's also increasing each term by 1. So even the run part is +1. Okay, if you can simplify your fraction, guys, you want to make sure that you do. And so 1 over 1 would be positive 1. Here's another example, guys, of a slope that's in a table. What you want to do is look for your rise part, which is on the y-axis, 12, 16, 20. And each term is increasing by 4. Okay, so for the rise part, it's up 4. Then we'll look at the run part. Each term is also increasing, this time by 1. Okay, so even the run part is increasing, positive 4 over 1, or just plain old positive 4. Okay, guys, the next thing I want to make sure that we talk about briefly is what your equation should look like. Equations for slope are written in this formula that you'll see 100 times when you're in 8th grade, and it's called y equals mx plus b, where m is called the slope or the rate of change, and b is called the y-intercept. The y-intercept is extremely important, guys, because it's also called the initial value. It's called the initial value because that's the point that you graph on the y-axis first. Just like the first initial is in your name, this is the first initial on the graph. You would graph this first before you graph anything else, and then you'll use the slope to tell you where to go next. Let me show you guys an example of graphing an equation that's in y equals mx plus b form. If you guys look at my equation, my 1/2 would be my m, or my slope, or my rate of change. And my 6 would be my b, or my y-intercept, or my initial value. Remember, guys, that the initial value is important because that's the one that we graph first. I'm going to show you guys how to graph an equation like y equals 1/2 x plus 6 on the coordinate plane. I'm sorry, negative 1/2 x plus 6. Okay, guys, remember I call the y-intercept the initial value because you graph it first. Okay, it's the point where the line goes across the y-axis. Our initial value is positive 6. So on the y-axis, I'm going to find where positive 6 is. Would I have to go up or go down to get to positive 6? I'd go up. On the y-axis, it's right there. There's positive 6 on the y-axis. Remember, it is called the y-intercept. It's the point where the line goes across the y-axis. From there, guys, I can just graph my slope. My slope is negative 1 over 2. And remember that this is in rise over run. So how do you rise negative 1? You wouldn't go up. You would go down 1. And then you would run positive 2, which means you would go 2 spaces to the right. And if you want to extend your line, guys, you would just do the slope again and again and again until you're satisfied with how long your line is. You go down 1 and over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. So my line looks like this. And my line is a decreasing line, which it should be because my slope is negative 1/2. All right? Guys, one more thing that I thought was interesting that was in the very first lesson, because it kind of crowded everything together, is if you have a table and they want you to find the y-intercept. Remember that the y-intercept is where the line crosses the y-axis. I'm going to show you guys this one more time because the y-intercept for this particular line is at 6. But the ordered pair for your y-intercept, if we were to count to see where it is, we would go over 0 on the x-axis and then up 6 on the y-axis. So guys, what you need to remember is that your y-intercept is always has an x-coordinate of 0 and then your y-coordinate of whatever you find in your equation. So when they're asking you for the y-intercept, what they want you to do is kind of work backwards until you can get your x value to be at 0 and your y value will be whatever it is. Okay? So how can I go 5, 6, 7 all the way back to 0? It seems as though they want us to find all the coordinates that fall in between till we get back here at 0. So I'm going to fill these in. Each term was being counted by positive 1. So in order to get backwards, I'm going to subtract 1. This should be 5, 6, 7. So this must have been 4, 5, 6, 7. 3, 4, 5, 6, 7, 2, 1. Okay? Now let's look at the y's over here. Each term is being counted by 3, so I'm going to subtract by 3 because 16 plus 3 is 19, 19 plus 3 is 22. I'm going to count backwards. 16 minus 3 is 13, 13 minus 3 is 10, 10 minus 3 is 7, 7 minus 3 is 4, and 4 minus 3 is 1. So the y-intercept for this particular line is at 1. That means on the coordinate plane, if we were to graph it, the first coordinate I would graph would be 0, 1, and then I would go over 1, up 4, over 2, up 7, and my line would look sort of like that. So guys, I tried to cram all of that in 10 minutes. If you have any questions, please let me know. Thank you.